All right, good afternoon again, everybody, or good evening when you're watching this. So this is part 2 of the final for our review, okay? So please make sure that if you guys have any problems with this, that you come find me, and then we'll go from there, all right? First and foremost on this, starting with 24, all right, rewriting these equations based on the y-intercept, and then you rewrite them with the greatest y-intercept on top. So instead of rewriting them, you just actually need to go in Desmos, okay, and actually graph them. So on here are the three, starting with 2.5x plus 3, the 3x minus 7, and then lastly the 8. So if I go home and then I zoom out a little bit, you guys can kind of see where they intersect. So number 1 on the list is the black equation. So it would be 8 minus 4x. Number 2 is the green version, which is 2.5, and then last would be that. So if on the test you'd be asked to rewrite it, you'd go that minus 4x, you go y equals 2.5 x plus 2, and then lastly it'd be y equals 3x minus 7. All right, what are the zeros of the following function? Same thing, just graph it in Desmos, okay? When you guys go in there, when you graph it up, you do your y-intercept, so you have it. So I got -2, and then a 0.333 repeating, which is 1/3. Now, here's the aspect with this. So it's letter A. Here's the aspect with that. As we move forward, there's going to be a couple examples where I'm going to talk to you guys about making sure you know the answers. You can put it into either Desmos or a calculator to kind of get things situated in terms of what is the actual, like a fraction of an answer, like 1/3. What is that as a decimal? Okay. There's another example I'll show you later as well. Rate of change. 1, 2, 3, 4, constant. So you go from 15 to 60. If you did a constant rate of change, this number here would in fact be 30, and this would be 45. So what it is that these are equaling. So what number equals 30? Well, A would have to be 15. That's the only one with 15, so that's your answer. But if you wanted to keep checking as a constant rate of change from 15 to 30, 45 to 60. All right, make sure that it's constantly going through. You could go 15 times 2, which is 30. So 15 times 2 would be 30. 30 plus 15 is 45. It can be A, because if you put A in there, that would be 25. So you go 15, 25, 45, 60. That's not a constant. And it can't be 10 or 2, because that also is too low. It equals only 35, and then that's not a constant rate of change either. So please make sure you guys understand why I selected it like that, because it's a constant rate of change. All right, given the function below, circle all equalities that are true. So same thing, enter this in Desmos, okay? You enter it in, here's the setup. Now, on this, make sure you guys do the table setup. You hit the gear, do the table, okay? And then from there, you can put in your actual numbers. So let me grab my paper so I don't have to go back and forth. On this one, when you do your numbers, ladies and gentlemen, your setup would be as follows, okay? First one on the list, I believe, is a, let me find my spot, -6, okay? So your first one is a -6. It's 16, A is not an answer. If you do B, -3, the answer is 7, so B is an answer. 0 is not 4, or not 5, it's actually 4, so C is not an answer, but E is. And then lastly, G would be 4 and 0.33, so that's an answer. And then finally, number 9 is, you check 9, and 9 is 31 instead of 29 like on our sheet. So our answers are B, number 1, or letter D, which is G to the first. And then the other one is, it's basically bed, B-E, and then D, okay? Those are the answers that you would be able to find. Which two of the following values of x would make the expression below rational? Remember, a rational expression is a whole number. So if you were to go in here on Desmos, the only thing you would do, or a calculator, okay, is you can come in and start typing it out. So let's start with the first one, 8 times the square root of 3. That is not a rational number, right? Square root of 2, 4 is a rational number, so circle 2. And then change it again to 5. That is not a rational number. Remember, rational is a whole number. So the only other one it could be, in that case, is square root of 2 and 0. Given the function below, what statement is true? So 3 to the x, okay? 3 3 to the power of x. As I scroll down here, go back, turn this value off. 3 to the power of x is right here. So if I have this on, you do the same thing, the table feature. Do a table on here, and when you do that, you get your value of 1. So your value of 1 is 3, your value of 2 is 9. So when you're looking at your paper and it talks about a greater value, remember greater than is addition. So since it's addition, you know it can't be C or D, or in this case CC. It has to be multiplied. So is P2 3 times greater than the value of P1, or is it the other way around? Well, 9 is 3 times greater than 3, so your actual answer on this is B. All right, next, 30. Select the following equations. Graph it in decimals. These are your intersections, okay? And this is what I was talking about earlier. What if you graphed it in decimals and you got some weird answer like, so let me check it real quick, because I never did in class today. If I do check this answer, so number 30 is going to be, so let me start by putting a bracket around this. So number 30 is -3. So let's try one of these. -3 plus square root of 29. All right, 29, and then close the bracket, and then it's going to be divided all over 4. All right, so what if you did a example in decimals, okay? Or you did an answer and you got a point like this, where it'd be 0.596. You look at yourself and say, well, I don't know what that is as a fraction form. What you would do is come into decimals and you would answer or put in all of these values until you would actually match it up. So for example, if this doesn't match my per se number, and instead it was supposed to be a negative, bam, all right, maybe it was -2.09. Hopefully you guys understand. What I'm telling you is that if it's not a solid number where you know something, look at these numbers here, enter them in decimals, and compare your answers, okay? Simple as that. Use that test-taking strategies, and you guys will do fine. Intersections, 4, -6, okay? If you're doing that, you know A and C can't be an answer. Set these to 0. If you set them to 0, if I put a number 4 in this equation right here, 4 plus 4 does not equal 0, but 4 minus 4 does. That's the answer. 32, graph it. Ladies and gentlemen, when you graph this one right here, okay, you will get an answer of, you get it right here, it's the intersection, 1, -1, okay? So this one here is 1, -1. Just graph it. 33 talks about an inequality that is true. You would graph that. Make sure you change the values, okay, to x. So here's the inequality right here. Turn that one off as well. So my inequality, you're just what values in the shaded area. So your values that you start off with, of course, are 0. 0 is in the shaded value, so that's 1. 10 is not, so that's a no. -5 is a yes. 2 is a yes, because our inequality sign is equal to. If you did not have the equal to sign, it was just like that, then the answer would be no. But in this case, it's yes. 5 is a no. -3/4 is, of course, a yes. 34. Average rate of change. Now on this, ladies and gentlemen, from -2 to 0. Same setup, okay? When you graph this in decimals like this, all right, you want to do your table function. So when you do your table function at Z, you want to take your points. So as we talked about in class, the points are 0.7 and -217. So what I'm trying to do is I'm trying to find out the distance from here to here. Okay, what would be the rate of change between these 2 points right here? It would be, what it's talking about is, say you drew imaginary line. So you guys will learn this in geometry next year, where what if I drew a line that went through this point here and it went through that point as well, and it just kept going. Now that's a horrible line. Maybe, I think, because it would actually go inside a little bit, kind of like that. That's better, okay? So that's what it's talking about. What rate of change is this slope? Well, right away, I know this is a negative, so that's a good thing. Now what we'll do is we'll go see if we can figure out the rest of this answer, okay? So as you go back in here, I told you the points are -2 and 17, and then the other point is 0 and 7, okay? So y2 minus y1, x2 minus x1, and what does that equal? That's the slope formula. You plug in your values. So your first one, and it doesn't matter how you do it, remember that, 17 over -2 minus 7 over 0, that ends up being 10 over -2, which is -5. So hey, the rate of change is -5. 35. What description of h of x does the table support? So I got cut off on my slide, but yours it didn't. Put these in decimals, okay? You graph the points. When you graph the points, they look like this, and then you have to ask yourself, what kind of equation is this? Well, ladies and gentlemen, same setup, all right? If I were to draw a value on here, is it a straight line, a linear? No, of course not. But what this is actually an exponential equation. Okay, remember exponential is like a jet from our military days. I think something taken off and then it goes vertical, just like that. Okay, that is exponential function all the way. So this answer here is B. 36. The values of this are these two equations. When in doubt, ladies and gentlemen, if you want, multiply it out using the box method, please. Okay, so you'd have 9x and then a 9 negative x, and if you did that, you guys would see your setup, how it would actually translate to the value of 81. These cancel out, minus x squared. That's exactly what we have up there. 37. This function is just, you could graph it. I had one of my students in 6th hour, Emily, basically tell me, hey, I graphed it and just check the numbers. Sweet, great. You can check it, do the table function like she did, or you can plug these in. So what you're looking for, remember, is the value of t is going to be replaced by whatever number's here, okay? And what you're shooting for is this to equal 21. All right, your first one is 21, so just focus on that. 0, so if I put a 0 in here, that'd be -14, that's not it. If I put a 2 in here, that's 5 times 2 is 10, that'd be -4, that's not it. If I did 7, 7 times 5 is 35, minus 14, that is in fact 21. The answer is C. 38, you would write this equation out. Okay, 40 equals. First piece is 4 times. 4 times the length of the second piece, and the third piece is 3 times. So, as we mentioned in class, you write, here's your equation that you write out for your 3 pieces. Add your x's up together. Okay, your x's, it's not 3 x's, there are 8 x's, as was so commonly mentioned in some of the classes today. Divide by 8, x equals 5. Okay, x equals 5, that's not what we're looking for. We want to know what is the length of the largest piece of rope. So we want to know 4 times 5, which is 20. That's B. 39, which part of the statement below corresponds to the domain of a function? Well, ladies and gentlemen, remember, f of x is the same as saying y. So domain goes with x, range goes with y. So you would select that portion of the thing. So remember, dx, ry, huge thing to remember. Complete the steps. So we talk a little bit about this one as well, and which one of these equations is the first. As you go through, read the sentence. Here is your original equation. We stumped some people with that, and it was a good time in class. So this would be number 1. Then as you're going through it, which one of these is different from the remainders? Okay, you take this one out. Bracket, 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 no bracket. This is the second one. Okay, you wouldn't make it so that you have a bunch of brackets and then another one with no bracket at the end. You got to know that's 2, because what they're doing is taking the original and you're completing the square, which is you're adding and subtracting a 9 to both sides. Then if you look at what's left with the brackets, which one does not belong or look like the others? It's this one, okay? And then finally, you would go 4 and 5. So here's what I want to make sure you guys understand, okay? When you're doing this, understand that when you put these in order, they should make sense to you. Okay, they should be able to look at it and say, okay, this makes logical sense that I would start here add something here, then take the addition of something and rearrange it to this, and then once you get that, you complete the square part here, and then you just do the simple math here. That's your setup and how it should go. 41 is A. Just remember that, even though it was brought up in one of my classes, that D is actually the answer. But I want to make sure you guys understand that there are some things tweaked on this question, and on the test it won't be tweaked, and so you should answer it as A. 42, what is the average rate of change for the following function? Same thing happens. You graph it in Desmos, okay? And when you graph this in Desmos right here, all right, then you use the table function. Once again, you do the table function, you get your points, all right? When you do your points, ladies and gentlemen, that is when you want to make sure from there, so let me get rid of this other thing here. When you do your points, that's what you write down. So I'm going to give you the points right now. They are, I got to flip my page over. The points are, for 1, it is 6, and then for 3, the other point is negative 26. And then remember to do the rate of change formula again, which is y2 minus y1. All right, then you set it up. So my first one, I'm going to do the first point here as 6 and 1 minus minus. It's a negative 26, so that changes this to a positive 3. So this is going to be 32 over, oops, not 3. It's going to be 32 over negative 2, which is a negative 16. All right? So the answer is A. 43. Do the equation. Try to figure out what is different. So as I look at here, I look at things that are disappear from one side altogether. There are 2 numbers on this side, so they don't disappear. But if you look on this side of the equal sign, the 5x disappeared. So what did they do? They subtracted the 5x. Now, the result of that is 5x is gone on this side, and on this side, negative 5x plus a 3 is in fact negative 2. So sweet. The top one is good. All right, so cover that up. What's the difference between here and here? Well, the negative 2 looks like it disappears down here. So they add 2, add 2. The problem is negative 10 plus 2 is actually what? Negative 8. So the equation is wrong at that point. So that's how you figure that out. 44, factored form of this. You can either do this, factoring. Okay, that's the factoring, remember the AC. You can use the box method. Okay, multiply it out, so you could do like x minus 2 and x plus 15. Factor it out that way, see if you get this. Or, ladies and gentlemen, graph this one and then graph your 4 answers and see if they line up together. Okay, when the graph goes on top of each other, then, ladies and gentlemen, you have your answer. In this case, it is D. Very last equation, 45. Let me show you how to do this. Select 2 polynomials that have a product. So we're going to select 2 of these. You graph this. This is what this polynomial looks like in Desmos. Okay, it's kind of a crazy one, but this is something you'll do in Algebra 2. It's got kind of a little wing on it. It's a little sign. So what you're looking for is what equations share the exact same x-intercept. Okay, now there are 3 of them, so you know you're going to have at least a quadratic of some form and a regular linear line. All right, so which one of these shares? So, like for example, if I did x squared plus 4, there is no intersection down here on this, so it can't be that particular equation. However, if I do 2x squared minus 3x, if you guys notice, ladies and gentlemen, they share the exact same x-intercepts. So that is one of your answers, okay, because their x-intercepts are exactly the same. Because remember, x-intercepts are the equals, okay, so that's what it equals. So now what you're looking for is the very last one that intersects here. So if I click on this bottom one right here, it actually intersects way over here, so that's not it. The only answer it can be is actually x minus 2, and you see they share the same intersect right there. So if you guys see right there. So one thing I want to make sure you guys understand, even when you guys get to Algebra 2, you can solve these by doing it. So your answer is 2x squared minus 3x, and then x minus 2. You can even do this kind of stuff in Algebra 2 when you get there if you want to double check your answers. You would just highlight the graph, you would just graph the original, and then like a form factor like this, and then, ladies and gentlemen, you just graph what you got out and see if it actually matches. It's been a pleasure this year. Final video for Algebra 1 for 2018-19 school year. It's been fun. I will see you guys around the halls. don't be afraid to stop by. I have many former students that do, and I have a feeling since you guys are my second class at Williamsfield, it'll get a lot more crowded in my classroom, and we'll have a lot of fun. If you need anything from me, see me in school, please. There's only a couple days left. Study up. I know you will do well, and it's been a pleasure.